Today we're going to talk about the vocabulary of algebraic expressions. Algebraic expressions are not equations. They don't have an equal sign, but they have numbers and letters and so forth. And so we need to know what the vocabulary is, because when we ask you to do something in math, we're going to give you directions in English, and you're going to have to be able to translate those English directions into math. This is based on Blitzer's intermediate algebra. So, section 1.4 talks about the vocabulary. Now, if there are numbers and letters that are being multiplied together, that counts as one term. If you have constants, that counts as one term. Fractions can be a term. You can have x squares that are a term. A term is basically just separated by an addition or a subtraction sign. So here we have two terms. The coefficient is always the number in front of a variable. And so if I just have this variable right here, the coefficient of this is 1. We never write the number 1 in front of a coefficient. If there is 1, we just assume there's 1. So there's a 1 here, so the coefficient's what's in front. The variable is always the letter. That's going to be the letter. And the constant's going to be what doesn't change. A 4 is always a 4. A -3 is always a -3. So only like terms can be combined when you add or subtract. Now, like terms mean, sort of like what it sounds, things that are alike. They have to have the same variable with the same exponent, or they have to both be constants. So you can't combine x's with y's or 3's with x's and that sort of thing. Okay? So here we go. We have an algebraic expression, 5x plus 8 minus 3x. There are 3 terms in this expression, this term, this term, this term. The coefficient of the first term is 5. The coefficient of the second term is -3. The constant term is +8 because it's constant. And the like terms are 5x and -3x. I could combine those to get 2x. Now, let's simplify the algebraic expression by combining the terms. This is sort of the foundation of algebra, being able to put things together that belong together and not to try to combine things that should not be combined. So here we have some y terms. I have 9y's, -5y's, another y. All these y's can be combined together, sort of like your apples and your bananas. Or if you go to the store is organized into dairy products and canned goods and produce and meats and stuff like that. So you put those things together. You wouldn't want to walk into the dairy aisle and beside your milk and have a pair of shoes or a curtain or something, okay? You put things together that go together. So you have 9y's, you take away 5 of those y's, that gives me 4y's, and you add another y, so I have 5y's altogether. 9 minus 5 plus 1. I have a 6, subtract 3 gives me 3, plus 1 more gives me 4. So that would be the answer. Now, I can't simplify this expression anymore because I can't add y's to constants. If I have 5 apples, I can't add it to $4. That makes no sense. They're not the same thing. All right, using those, try to do these bottom ones. We'll check back. Oh, hopefully you did well. Okay, let's look at the next one. We're also in section 1.4 talking about the basic rules of algebra, okay? There's something called the commutative property and associative property. There's a lot of properties actually, but these are a couple of them. So the commutative property basically says that when you're adding things together, you can write them in any order. 2 plus 3 is equal to 5, which is the same as 3 plus 2. I could write those in any order. Sometimes that comes in handy because usually when we're solving equations in algebra, we want to have an answer that says x is equal to something, right? X is equal to 7, x is equal to 2, x is equal to whatever, -10. Doesn't matter. But sometimes when you're working out the problem, you might get something that looks like this. 7 is equal to x. Well, that kind of looks backwards in the math world. So it's okay to change 7 is equal to x is equal to 7. Doesn't really matter, okay? Also, when you're multiplying, you can add or multiply 2 times 5 is the same as 5 times 2. Those are the same things. And that comes in handy whenever you say something like x times 4 is the same as 4x. in math, this is generally more accepted. This is not so accepted to write it that way. So you always put the coefficient in front of the variable. So just, kind of these little tricks help you get the answer to look like what your professor will ask. An associative property means that you can multiply numbers and letters in any order. You can combine them in any way you want to. So A times B times C is the same as A times B times C. And if you put numbers in here, you'll get the answer. You'll see that mathematically it's the same. So using the commutative property, let's write an expression. So this, if y plus 4 is going to be the same thing as 4 plus y. 10x plus 3y is the same thing as 3y plus 10x. 5 times this stuff, 5 times what's in parentheses is the same as saying what's in parentheses times 5. You could write it in any way. Now in math, this would be more appropriate, this would be more appropriate, and this would be more appropriate because in math, we always write our variables before our constants. We write our variables in alphabetical order. My x's come before my y terms. And then we always write constants in front of parentheses because you would then distribute. But just so you know, they mean the same thing. Here, again, you can use the associative property to say if I wanted to add the 5 and the 2 together, then the 8, I would get the same answer. Similarly, if I wanted to add the 4 and then the x plus 1, you could do that. You could also do 4 plus 1 plus x, because then that would give you 5 plus x or x plus 5, and that's fine. And this could be the same thing as 8 times 3 together times x, or you could say, well, that would probably be the way you would do it, like 24x. So you can either group the 8 and the 3 together first, or then the 3 and the x. Yeah, so you would end up getting 24x. Okay, so do the ones down here. There's a variety of different answers that are correct. Try it out. Alrighty, this is what I got. Hopefully yours is similar. Okay, basically just saying that you could write those in different ways. All right, so again, looking at section 1.4, basic rules, we had the commutative property and the associative property. Now we're going to look at one of the most important properties in algebra, and that is called the distributive property. So whenever you distribute, it gets rid of parentheses, okay? That way you have everything all outside of the parentheses. So I could distribute the A to the B and to the C because A is being multiplied by everything in the parentheses. So since A is being multiplied by everything in the parentheses, I could end up with A times the first term plus A times the second term, or minus. If there's a plus or a minus, it doesn't matter. Now remember, this is not the same as multiplication. So A times B times C, it wouldn't matter. You don't distribute that. But whenever there's a plus or a minus inside the parentheses, that's when you do that. We typically don't have this in algebra. It's sort of a backwards way to do things. We do it the other way. All right, so simplifying algebraic expressions. So the first thing we want to do is use the distributive property. Get rid of the parentheses. Group all your like terms together, all your x's together, your y's together, your constants, and so forth. And then combine your like terms and combine your constants. The simplified version is going to be where all of your y's are together, all of your x's are together, all your constants together, all of your variables are together, so forth. That can be combined. So here we're going to use the distributive property. All right, so you get 2y plus 8. I can't combine y's with 8's, so that's as simple as it gets. Negative 2 times positive 4 is negative 8, and I have y's because they're all being multiplied. And negative 2 times negative 5 is positive 10. So I took this negative 2 and I multiplied it by both parts. Now, if you look inside the parentheses, the x's and the constants and the y's cannot be combined. So I can distribute the 5 to all three terms. So 5 times 3x is 15x. 5 times negative 2 is negative 10. 5 times positive 4y is positive 20y. Now I would normally rewrite this as 15x plus 20y minus 10 because you want your alphabetical order of your variables, and then your constants are left at the end. Also, let's do this one. Okay, we have a distributing process that can go on. So 5 times 2x is 10x, and 5 times 4 is 20, and there's an addition sign in the middle, plus 3x minus 1. Now, we just learned that we can combine all of our x's together. If I have 10 x's and 3 more x's, I have 13 x's in all. And I have 20 minus 1, I have 19. Now, there's more positives than there are negatives. So if I take a positive 20 minus 1, I'm going to get a positive 19. All right, now you try this. And once again, here's what we have. All right, look forward to seeing you in section 1.8.